Okay, we're going to talk about torque. And so the idea with torque is that torque is defined as a vector, and it's defined to be R cross F. And so really what's going on here is that in this case, suppose I want to loosen or tighten this bolt. Suppose I actually want to loosen it. So I want to twist it such that the thing goes in that direction. That's counterclockwise, and that's a positive direction. Now to do that, I can pull on this wrench with a force. So let's look at a couple different options. One force might be out at the very, very end and would be pulling at a right angle. Another option would be to pull somewhere in the middle and still at a right angle. And finally, you could take and pull from the very end, but let's suppose we didn't pull at a right angle. We pulled at some arbitrary angle. And so the question would be, which one of those torques is going to be greater? Or really, which one is going to tend to twist the wrench the most, or is going to, in essence, allow us to apply the greatest leverage? So there are two things that go into this torque equation. One is the radius. So in this case, this would be the radius. The radius would be the length of the wrench. And then the force, let's say we'll call this one force 1, force 2, and this one force 3. Well, it turns out that force 1, force 2, force 3 are all vectors, and force 3 is not at a right angle with the wrench, and that actually also has an effect. So what we're going to do is we're going to write R times the magnitude of the force times the sine of the angle between the radius vector and the force. And in the case of force 3, let's just look at this. This is my L, my radius vector, and this is my force 3. It turns out that the only component of the force that has an effect is the perpendicular component. So that component of the force is perpendicular to my L vector, and that's the one that's going to have the greatest, or have the only effect. The component that is parallel to the force has no effect on torque and provides no turning force. And that would make sense. If I'm looking back at my wrench, if I pull on the wrench like this, it doesn't help turn it. What I want to do is apply as much force as I can, in that direction. So assuming that the forces are all the same, just different angles, you can go back and see pretty obviously that the torque due to the second one is going to be greater than the torque due to either 1 or the torque due to 3. And again, we'd have to know what the angle was in order to determine. But if I say that the angle is 30 degrees, then F perpendicular is 1/2 of F3. And in that case, you'll see, and in that case, torque 2 will be greater than torque 1, which will actually equal torque 3. because going back and you'll see that this, in this case, this one has a radius vector of L over 2, and this guy here has a force perpendicular, which is half of force 3. So assuming all these forces are the same.